Metabolism of fructose and galactose. So this video will be talking about the entry of fructose or galactose into the liver or the muscle cell, and also outlining where fructose and galactose enters the glycolytic pathway. Fructose is more complex in that the point at which it enters the glycolytic pathway will differ based on the liver compared to the muscle tissue. First, we will talk about the metabolism of galactose. And you can see galactose here at the top of the screen. And for galactose, we'll have it entering the liver cell only, and it will enter the liver cell through the GLUT2 channels. And if you will need a review of the GLUT channels or transporters located on different tissues, on the various organs in our body, and the GLUT channels that are used for each monosaccharide, you can review this table 3.2, which is in your text. I'm not going to take time to review the entire table at this time, but you can take this time to review and focus particularly on GLUT2, GLUT4, and GLUT5. So back to the metabolism of galactose, and we have it entering the liver cell through the GLUT2 channels or transporters. And the first step, we have galactose being converted. You can see galactose here. Galactose entering the liver cell and first being converted from galactose to galactose 1-phosphate. In this first step, we have an investment of 1 ATP, and the galactose essentially binds a phosphate group and is converted to galactose 1-phosphate. The next step, we have conversion of galactose 1-phosphate to glucose 1-phosphate. And then the next step from there is conversion of glucose 1-phosphate to glucose 6-phosphate. We know from previous discussion of glycolysis that glucose 6-phosphate is an intermediate of step 2 of glycolysis. So it is at this point that we have galactose entering the glycolytic pathway. Next, we have metabolism of fructose. And as we discussed previously, the metabolism of fructose is going to depend on the liver compared to the muscle tissue. So we're first going to talk about fructose metabolism in the muscle, and that's going to be illustrated using this line here where we see the conversion of fructose to fructose 6-phosphate. First, though, to discuss the channels, in the muscle tissue, we have fructose entering the muscle through the GLUT5 channel. So we have fructose entering through the GLUT5 channel of the muscle, and we have conversion from fructose to fructose 6-phosphate. Also during this reaction, we have investment of an ATP molecule, and so we see essentially like with galactose, fructose binding to a phosphate group and then being converted to this fructose 6-phosphate. You can also see this conversion process demonstrated in this diagram. Shows here we see the muscle tissue, we see fructose being converted to fructose 6-phosphate, we see an investment of ATP, and also we see the enzyme hexokinase being involved in catalyzing that reaction. This is relevant because from previous conversation of glycolysis, we know that fructose 6-phosphate is an intermediate of glycolysis. It's the reactant of step 3 of glycolysis, with step 3 of glycolysis being that rate-limiting step with the rate-limiting enzyme PFK. So now we want to compare the metabolism of fructose in the muscle, and again we have in the muscle fructose being converted to that fructose 6-phosphate. We have investment of ATP and the enzyme hexokinase. So we're going to compare that metabolism which we reviewed and occurring in the muscle to the metabolism and conversion of fructose in the liver. The metabolism of fructose in the liver is demonstrated by this arrow where we see the conversion of fructose to fructose 1-phosphate. In the liver also there's a different channel, so we have fructose entering the liver through the GLUT2 channel versus the GLUT5 channel which was used in the muscle. So we have fructose entering the GLUT2 channel in the liver. We have investment of an ATP, we have the binding of a phosphate group to fructose and conversion to fructose 1-phosphate. From here then, we have the eventual conversion of fructose 1-phosphate to glyceraldehyde 3-phosphate. So that fructose 1-phosphate that has bound a phosphate group in the liver then gets eventually converted to glyceraldehyde 3-phosphate and then goes on through the rest of the glycolytic pathway. You can see that demonstrated in more detail here in this diagram. In the liver, we have fructose being converted to fructose 1-phosphate. That is by the enzyme fructokinase. We have the investment of an ATP. And then we have the fructose 1-phosphate being converted eventually to glyceraldehyde 3-phosphate. The remaining pathways and steps, enzymes and intermediates you will not need to know, but it will be important to know that we have fructose going to fructose 1-phosphate with the fructokinase enzyme. We have investment here of an ATP and then eventual conversion to glyceraldehyde 3-phosphate. Comparing this to fructose metabolism in the muscle, where we saw that fructose was converted to fructose 6-phosphate, which is reactant of step 3 of glycolysis, step 3 being the rate-limiting step of glycolysis, we see that with the liver, we have conversion of fructose to fructose 1-phosphate and then to glyceraldehyde 3-phosphate. So this glyceraldehyde 3-phosphate is occurring after the rate-limiting step of glycolysis, and therefore you can see that fructose metabolism in the liver would not benefit from this regulatory step, since again glyceraldehyde 3-phosphate is an intermediate occurring after step 3. So in our discussion activity this week, we're going to be talking about the implications of this essentially unregulated process of fructose metabolism in the liver.